Example 13.8 says calculate the mass of HClO4 needed to make 5.13 molality solution in 239 grams of water. So HClO4 is going to be our solute, and water is going to be our solvent. But they gave us the molarity of the solution. So that means that I have 5.13 moles of HClO4 in 1 kilogram of H2O. So how do I know it's 1 kilogram? Well, 5.13 divided by 1 is just 5.13, and that's why that makes sense. But they said that they want to know the mass in 239 grams of that solution. So if I'm looking for mass of HClO4, I'm going to have to get the moles of HClO4 by itself. So by doing that, I'm going to have to find a way to get rid of the kilograms on the bottom. So if I want to get rid of the kilograms on the bottom, what am I going to have to multiply this to in order to do that? I'm going to have to multiply by the kilograms of water. So I have to first convert 239 grams of water into kilograms. So 239 grams. And I want to get it to kilograms. And for every 1 kilogram, there are 1,000 grams. So that's 0.239 kilograms of H2O. So that's going to go 0.239. And I'm going to put a 1 on the bottom. So those kilograms are going to cancel, and now I'm going to be left with just moles of HClO4. So I calculated 1.226 moles of HClO4. So I have 1.226 moles of HClO4. But the question is asking for the mass. So how do I go from moles to grams? I'm going to need to know the molecular weight of HClO4. So I need my periodic table of elements. And so I know hydrogen has a weight of 1.008, and there's one of them. Chlorine has a weight of 35.45, and there's one of those. And there's 4 oxygen. So I'm going to do 4 times its molecular weight of 16. So the molecular weight of HClO4 is 100.458 grams per mole. So if I want grams on top, I'm going to have this value on the top. And moles on the bottom. That way I can cancel out the moles and I'm left with just grams. So the answer to this problem is 123.2 grams of HClO4. The next type of concentration is the mole fraction. We will use a capital X sometimes to define that. So the mole fraction is the number of moles of that component divided by the total number of moles of everything in the solution. So sometimes we'll say the mole fraction of blank, and what we mean by that is the moles of that divided by the total moles. So if I have 2 components of A and B, the mole fraction of A is calculated by this equation. So capital X just represents the mole fraction of A is equal to the moles of A divided by moles of A plus moles of B. And then the sum of the mole fractions of any solution is 1. That's not per se the bottom number. That actually just means that XA plus XB is equal to 1. So if there's 2 components, then adding those mole fractions up will give you 1. And then also mole fractions do not have units because moles divided by moles will just give you one number. Example 13.9 says calculate the mole fraction of methyl alcohol in a solution composed of 1.46 moles of methyl alcohol and 2.19 moles of ethyl alcohol. So let's start with that, and then it says what is the mole fraction of ethyl alcohol. So to find the mole fraction of methyl alcohol, so that's going to be CH3OH, that's just going to be moles of CH3OH divided by moles of CH3OH plus moles of C2H5OH. Oh, sorry. Yeah. So they gave us those values. That's just going to be 1.46 divided by 1.46 plus 2.19. So the mole fraction of CH3OH is equal to 0.4, and there are no units. Now, it also asks what is the mole fraction of ethyl alcohol in the same solution. Well, I know that the sum of two components is just going to be equal to 1. So if I'm looking for the mole fraction of this one specifically, I can just say 1 equals 0.4 plus x and solve for x. That's just going to be 1 minus 0.4. So the mole fraction of ethyl alcohol, so C2H5OH, is just going to be 0.6. You can also do the math by plugging it into this equation. So you can also do it like this. So it's going to be 2.19 divided by 1.46 plus 2.19. And that will give you the same value. Here's a really good table that summarizes all of the types of concentrations and their units. It is so important to know the definitions of everything because they're so different between them. For instance, molarity is moles of solute divided by liters of solution. Percent by mass is grams of solute divided by grams of solution. And then molality is very unique because it's moles of solute divided by kilograms of solvent, not solution. And then the mole fraction is dealing with moles divided by moles. So moles of solute divided by the total moles. So they're all very different from each other, but you're going to have to know to go between them. And the best way to do that is to know their definitions. Know what the numerator is and know what the denominator is.